Wait for
A very good morning to all of you and a warm welcome to the 11th session of our esteemed webinar 24 in 2024, a series by Whiteboard Education and Research Foundation in association with Deltron Technologies. It's an absolute pleasure to have you all join us today as we continue our journey of bridging the gap between corporate and education. Once again, we are back with our enriching session, and this is your host, Dipanshi. It is my pleasure to introduce our esteemed guest speaker for today's webinar on cloud computing and its impact on software development. We are honored to have Mr. Kaustav Sarkar with us. Mr. Sarkar is currently a software engineer at Google, where he plays a vital role in developing cutting-edge technologies. His impressive career includes previous role as a senior application developer at Oracle and a big data developer at TCS. With his extensive experience and deep knowledge in the field, Mr. Sarkar brings a wealth of insight into how cloud computing is transforming the landscape of software development. So please join me in welcoming Mr. Kaustav Sarkar. Before we start, I would like to tell to the audience that their mics are muted. So if anyone is having any query or question, they can ask in the chat box. In the last 15 minutes, we'll be having a Q&A session where your questions will be answered. Now the virtual stage is all yours, sir.
Thank you, Dipanshu. Thanks for that amazing
Thanks.
introduction. I think yeah. It was great.
Thank you, sir.
Thank you. So let me share. I have a deck which I want to share. And go ahead. Yeah. The option. So let me slideshow. Just give me one minute. How do you present? All right, everyone. So today we are going to discuss about cloud computing and basically what's happening in cloud computing and what are we doing with cloud computing and software engineering and how it's very important. So just to, I just want to confirm once, are you able to see my screen? Is the presentation visible?
Yes, sir, your
Just,
presentation is visible.
all right, great. Cool. So I just want to make sure that whatever questions you have, I mean, you are feel free to stop in the middle or just put that question in chat. I would be more than happy to answer your questions in the beginning of this presentation. And I really want it to be a two-way presentation. So yeah, just ask me any questions you have, and if I know the answers, I will try my best to answer your questions. Okay. So
Sorry to interrupt you, sir, but it would be great if you speak a little louder because your voice is not that much audible.
oh, my bad. I'm really sorry. So, is this voice better, or should I be
Yeah,
louder?
yeah, it's great, sir. No, no, it's good.
It's good. All right. Okay. So I was saying, just feel free to ask any questions you have in the middle, and feel free to stop me. All right. So first, let me. I mean, Dipanshu already gave a really good introduction, so I don't have much to talk about me. But apart from that, if you want to connect with me, uh, feel free to connect with me over LinkedIn, GitHub, or Twitter. I'm mostly active on LinkedIn, and we can collaborate on any project if you find it interesting on GitHub. I have a lot of personal projects which I keep on doing. So if you find something interesting, just hit me up on GitHub. And I'm also very much active on Discord. So you can find my Discord link on my LinkedIn profile itself. So feel free to connect there, and we should talk about things there So now let me talk a bit about history of computing, cloud computing, that where it all started. All right. So first of all, what we did was we had network and client server computing. So what it actually means is that you have a server side thing, whereas it's a central location where all your software programs and data and all your control is there. And what the users used to do is they used to connect to the server. They needed to have all the access so that they could read that data and they could run programs. And via a network connection, what they could do is they could run all that data. They could run whatever programs they wanted to run. So it wasn't very, nice and
Excuse me,
good
sir.
at.
Uh, excuse me, sir. So your voice is
Sorry.
not actually that much clear.
Uh, Let me try to do one thing. I have a backup. Uh, Let me connect with my phone then. It would be better.
Okay, no issue, sir.
All right. I'll keep sharing it from my laptop, but I'll just disconnect everything from here and I'll connect from my phone. All right. Let me. Let me also turn down my speaker. Sorry for that. All right. Are you able to hear me now?
Yes, sir. Yes, sir. It's good now.
Okay. Is it much better?
Yeah, it's a lot better.
It's a lot better. All right. Great. So, cool. Let me start. Let me just start again. Basically, first we started with client and server computing, or basically it was a network computing, where we had a server with all the data and all the softwares which were running on a single location. And what used to happen is that people used to connect to those servers, and then they used to run all their programs or access their data using those servers. And people quickly realized that, look, this is not happening because it's
Sir, your voice is gone. No, sir, not yet. I'm not even able to listen.
actually, sorry, I was muted by, please do not mute. Yeah, yeah. I'm really sorry, I was muted. Uh, till which point did we hear? Was I audible? Am I audible now?
Yes, sir. Yes, sir. You are audible now.
Okay, 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 okay. Okay, so basically, what happened was that system of network wasn't very efficient and it couldn't scale much. Right. So what we had to do is we had to move towards distributed computing. Now, when we talk about distributing computing, it means that we had multiple computers deployed at a lot of different geographies, and those resources were shared among users. All right. So now After distributed computing came the concept of cloud computing. Now, cloud compute, the concept of cloud computing, as we believe, isn't very recent. It's very old, and it was a concept of 1960s to be, if I want to be very specific. And there was a computer scientist named sorry, not James, John McCarthy. He's the gentleman whose photo we can see here on our slides, and he was the one who proposed that there would be a time when we would be sharing our resources for doing technological stuff, and that's where the technology would boom like anything. And that was a very good speech which he gave at MIT. Although, I mean, he was there, he was still alive during the initial phases of cloud computing, but he couldn't see the real power of it. So let's celebrate that there were such visionaries even during 1960s who had this vision that there would be something called distributed or shared computing, which would happen, and it would happen all via means of cloud computing, or what we currently call cloud computing. So where it all started, basically, first cloud computing, or we can say that the sharing of resources or sharing of software happened with Salesforce in somewhere around 1999, when the Salesforce was providing their enterprise application to via a very simple website to other enterprises. However, the things started changing with Amazon Web Services. That was the first cloud computing company which came to business and which was providing infrastructure to other businesses. So Salesforce was only providing an application, but Amazon Web Service was the one which provided infrastructure. So how did it actually happen? So we all know that Amazon was doing e-commerce. And what was happening during early 2000s was that the e-commerce business was booming like anything. So what they wanted to do is they had to scale their infrastructure a lot. So they had this internal project where they were trying to do scale their infrastructure, add more servers, and then they were trying to create a system by which they could manage their servers and all that infrastructure automatically and with very less human effort. So during all that effort, what they really found is that they actually are really good with doing what they were doing with servers and managing servers. So from that particular thing, they thought that, all right, if we are doing such a good job with managing our own servers, why can't we do it for other people? So from that, they started Amazon Web Services, and in 2006, they launched their infrastructure where they were providing cloud computing, basically EC2, which we know today. And later they also rolled out things like S3 and their RDS, which was basically a database. Now, where is it now? Where is cloud computing today, and what are we doing with all the and what are all the different companies which we have in cloud computing? So, I mean, I had to talk about Google Cloud. That's obvious. Then we have Amazon, which is doing really great, and it has a huge cloud share compared to any other cloud computing service. We have Microsoft Azure, we have Firebase, we have Oracle, Vercel, Heroku, DigitalOcean. So let me give you a brief about what are the benefits of each and every cloud, so that you know that before starting building your software, so before starting up, if you are doing a startup or something, what are the things which you should be aware of, right? And do we have? I think we have questions. Do we have any questions? No questions. Okay, I wasn't audible before. Okay, I just want to confirm my screen is visible, right? Uh,
Yes, sir,
the
it's
slide.
visible.
Okay, great. So if we talk about Google Cloud is, if we compare it with their counterparts like Amazon or or Azure, Google Cloud is much cheaper. Google Cloud has very good uh, services which we can use and which are very easy to deploy our applications are App Engine and Cloud Run. So if you haven't explored around it, please feel free to explore around App Engine and Cloud Run. They are really, really good. And if you move towards a bit more specialized offerings, we have Cloud Spanner. Cloud Spanner is basically one of the most impressive engineering marvels which Google has created. It's a distributed relational database which actually which has disproved CAP theorem. Basically, what it does is it's distributed across the globe and it provides amazing consistency and amazing atomicity of your data. Let's talk about BigQuery. Now, BigQuery is something another amazing thing which Google Cloud is providing. It can store exabytes of data. I'm not talking about terabytes or petabytes, but exabytes of data, and you can use all that data for your analytics, processing, training your AI, or whatever you want to do with that. Then the next amazing thing which Google Cloud has is Vertex AI. Again, Vertex AI is a complete solution for all your AI needs. Okay, enough about Google Cloud. Now let's talk about why would you choose AWS. Now, let's say if you are a business who is ready to spend a little more, but is more concerned about all the services, all the all the plethora of services which you can get from AWS, and all of them would be managed. So if you are someone who is concerned about that, or who wants that, you would go to AWS, because AWS is much mature than any other cloud service provider, whoever is present out there right now, and it is much more reliable than any other cloud provider. I mean, with Google Cloud, we have found certain instances where people have lost their data, lost their instances across regions. But if you talk about AWS is much more reliable compared to that. Now, what are some of the amazing stuff which AWS would provide and which other services do not tend to provide, or the services are not that good? So the very first service which I would like to tell you about is DynamoDB. Now, DynamoDB is again another engineering marvel which was created by Amazon, and it provided transactional benefits and transaction flavor to all our to NoSQL database as well. So DynamoDB in itself is basically a document type database, and it also has features of asset features of a relational database. So it's really amazing thing which AWS has provided us. And along with that, they have a large number of services which are related to file saving. Like they have Glacier, they have S3. So if you have something which you just want to throw in and do not want to use for a very, very long time, Glacier is your system which you can use. It's really cheap to save data, a little expensive to read, but really, really cheap to save data. And S3, like we know, it's a normal day file storage system where we can store all our files and images, PDFs, or whatever we want to do. Then AWS has another very good, a very interesting system, which is Kinesis, which is basically a pub sub system, which other cloud services have, but they are not that mature. AWS is Azure is something which is catching up, and it's almost there. It has all the amazing services, especially OpenAI. We know about that, right? So Azure is again another very good thing. I don't have much to talk about Azure, so I'll move to another uh, amazing cloud service, which is Oracle. So why would you choose Oracle? Now, Oracle has a lot of free tiers like which AWS, Azure, Google, all of these provide. But one of the most important and interesting things is that Oracle also provides free tier in databases. And that is what I'm talking about is relational databases. None of the other services would provide you a free tier in relational databases, which is as lucrative as Oracle. And we all know that Oracle is one of those services which is known for its databases. And Oracle has ruled this space since decades, since 1970. So it's been about 40, 50 years It's been ruling this space. We have other databases like Postgres and MySQL and all of that, but when it comes to enterprise level database, Oracle is still the first choice, and most of the banks, financial services still prefer Oracle over any other database. Now, let me talk about another amazing service which I personally use a lot as well, and that's Firebase. So, why should you use Firebase? So, let's say if you're starting up, or if you're a college student, or if you're, if you're doing a personal project, Firebase is something which you can use for hosting your application, right? It's almost free. You charge very less, and you would be only charged if you have a lot of traffic. And if you have started gaining that traffic, it means that you are earning. So it's free and it pays for itself for the initial few years. Then it has another amazing database called Firestore, which is a document type database. Then they have free authentication. They have free authentication for, I think it was either 15, 20,000 or 50,000 users. So if your application has 50,000 users, you are already doing pretty great and you should be ready to pay. Then we have Cloud Functions. Cloud Functions is actually almost free. The only thing they charge from you is for storing your code, and they have about million or 2 million hits free. Plus, they have several gigabyte seconds free for you to compute. So whatever, let's say, servers you want to build or servers you want to deploy, you can deploy them in Cloud Functions, and it would be free. Then they have another interesting service called FCM. Now, if you're building an application, then what you have to do, what you often do is send notifications to your users, or you build certain kind of notification system. So FCM is something which is completely free. It doesn't matter how many notifications that you're sending or to how many users you're sending. You can just use it as it is, and you don't have to pay anything for that. So I think it's quite interesting in that respect, and I personally use Firebase a lot. So when you are starting up, we will go into a little more detail around what are the impact of cloud computing and startup systems and basically software engineering, and uh, what are the different things which we should keep in mind when we are building our product. And one of the most important things when we are building our product or when we are designing our systems is money. Now, when you are starting up, or like I mentioned, you are a student in college, or let's say you are doing a personal project, you are not you don't have that much cash to spend. Now, let's say there are certain systems which I have worked on at Google, where we have say 12 servers running in production, right? Each of the server has like 20 gigabytes of RAM, and they have huge amount of CPU computing power. And the system which I'm talking about is a very small system compared to the scale which Google is working. All right. But still, even for a small application, a company like Google can spend that much amount, and it's basically nothing for it. But if you're a startup, you cannot have 12 servers running from the very first day of your application, right? You cannot have multiple different servers running for different environments, like test environment, development environment, or the production environment. All right, you don't have that much money. So what should you do for such instances? And how should you design your system? Now, cloud computing comes as a rescue, right? Now, if you are a small business, you do not have to keep your own servers at your garage or in your bedroom and have to worry about providing electricity and internet connection 24/7. And mind you, I mean, the internet connection which we get at home is nothing compared to the internet connections which we have at data centers of all the cloud systems. All right. So you don't have to worry about it. But one more thing which you have to be worried about is how much you're paying for all the services which you're using from all the cloud service providers. All right. We have to very much aware of those facts, and we will talk about it. We'll talk about it. What things we have to consider when we are building our own systems or building our own softwares. All right. Now let's say if you are a very successful business, you are a mature business like this gentleman here, you have money to spend. You have money to spend on infrastructure, you have money to spend on streamlining your processes. Unlike a startup environment where we have to optimize for money and we keep people to do most of the jobs which a system can do, in a matured business, what you can do is you can remove that redundancy of people and make systems do their jobs. And that's why we often see a lot of layoffs happening when a company starts growing, because a lot of the things start uh, automating and we don't need as many people as we want. So, I mean, yeah, it's basically something which is a boon to someone. It could be sometimes also have some effects which are not very favorable to us. All right. So yeah, let's move forward and see what are the kinds of trade-offs which we have to think about when we are building our system. Now, whenever you're building your system, right, what you have to think about is where do you deploy your code which has to run and where do you deploy a server. So at a very high level, we have three such options, which all more or less all the cloud systems provide. So one is going serverless. One is having a dedicated VM, like an EC2 instance, which AWS provides, or a cloud computing system, which GCP provides. Now, what are these EC2 instances, serverless, and Kubernetes is something. So, yeah, Kubernetes is something a cluster. I'll explain you all of these and briefly and very quickly, and we will discuss how we can use our systems and how they save cost and what are the scenarios in which we should use these kind of systems. So first is serverless. When is the time you should use serverless and what is serverless? So first, let's discuss what is serverless. So serverless is something where you I have a laptop in front of me. A laptop can run 24/7 if I just keep it powered on, right? So when my laptop is on, what I'm paying for is its computing power, its RAM, and the power which I'm spending on it, right? But my application could be small, and I might not be getting as much traffic uh, as like I might not be getting traffic 24/7. So what should I do? So the way my users are interacting with my systems is like uh, in the morning from 9 a.m. to say 12 a.m. I have good amount of traffic, and then I do not have traffic for most of the day. And then from 6 to 7 I see some traffic because that's the time when my systems are used. And there are some certain points within the day when my system is when my application is used. So what I would want is I would want a system which can stay up during those hours when I get most of the traffic. Right. So these are the points when serverless architecture or serverless computing comes into play, and they are very useful in those conditions. So serverless systems would only be active during the time your application is being accessed. And once your application is not accessed, serverless systems stop billing you. So they're really good when you have less traffic, when you do not have uniform traffic across your day. And what you want is to optimize your cost. The next thing is a dedicated VMs. So dedicated VMs like our laptops or our CPUs keep running 24/7, and uh, they are just there serving your traffic continuously. So when would I use a dedicated VM? I would use a dedicated VM when I have a uniform traffic across my day. So it's not like there are certain hours in day when I'm getting a lot of traffic, or like I have very few users who are like 100 or 200 users who are not using my application that often. So my dedicated VM is useful when, say, I have thousands of users across the globe, and they are continuously using my application. And there's hardly a few hours of time when my application is not being used, but most of the time it is being used. So in such cases, a dedicated VM would cost you much less compared to a serverless system. Because serverless system, if run 24/7, would cost you a lot more than a dedicated VM. I mean, huge. huge cost would be there for a serverless compared to a dedicated VM. Now let's talk about Kubernetes or clusters of VM. So let's say now you have millions of users, you have hundreds of thousands of users, or you have millions of users, and every day you are getting thousands of such users on your system who are interacting with tens or hundreds of your services. You are a huge business, you have a large number of applications, and you have a large number of services deployed across your cloud. Now, what would you do? You would use Kubernetes there because your dedicated VMs cannot scale. Even if you put, let's say, 100 VMs, it would be very difficult to manage those VMs. Why? Because your laptop tends to break, right? I mean, whatever laptops we use, they're good for 5 years, 6 years, and then they tend to break, and we don't know when it's going to break. So if your dedicated VM, which is hosting a very important service, breaks, your entire system is down. Your entire service is down, and the users cannot use the system. That's not something which you would want. So what you would do, you would go to you would want to have Kubernetes servers, and you would want to have clusters of your services deployed. So each of the service would be deployed on more than three servers in an ideal scenario. And all your different applications would be deployed across the globe and in clusters. So even if something goes down, there would be other servers which can handle your traffic, and Kubernetes can help you turn up a new server and deploy all your code there. Now, just think about it. Just think about this thing. What if we didn't have cloud and cloud service providers? We wouldn't have been able to use these amazing services which the amazing engineers in all these companies are creating. These, I mean, you wouldn't have a serverless system. You would have to have a person who would be turning on your servers and turning off your servers whenever there would be a person using, whenever there would be unexpected traffic. And if your server is switched off and there were users who came to your system, they wouldn't be able to access it, right? Dedicated VMs. Again, you would have to ensure that you have power 24/7, right? Now, let's say if there is a storm in your area, you you would lose your VM and you would lose your internet connection or power, right? So that's where cloud systems come very, very handy. And that's the major reason why people wanted to move towards cloud and rather than hosting their own bare metal servers, which was the case for people who were there, I mean, around 1980s and 1990s. What people used to actually do is they used to have their servers in their offices and in their homes from where they used to serve all the traffic. It would still work, but one of the problems that you would face is apart from power and 24/7 internet connection, another thing you would face is static IPs. So whenever your system, whatever system you're using is connected to the internet, it has an IP address of it. But that IP address isn't constant, it keeps on changing. And what you have to do is you have to buy a static IP from your internet service provider. So that's again going to cost you. But all of these things you don't have to think about when you're using cloud services, right? Now let's move forward. Now, yeah, data is something which is very, very important for any of the application, and data is just not gold, data is oil, right? And we have to know that how we are saving our data inside cloud, where we are saving our data inside cloud, and what kind of data I have, and what kind of application I'm building, and where should I deploy my data? Where should my data reside? And what are the different what are the different solutions which I have for deploying my data? So let's talk a little bit about that. So, all right. So at a very high level, we have three types of data which we can store, right? So the first type of data is relational data. The second type of data is not so structured data, but it's basically structured, but it doesn't have relations as such. And the third thing is blobs, basically uh, images, PDFs, videos, right? For those we use file storages. So now, what kind of database you should be using, and what are the cost implications, and how do cloud providers actually handle these scenarios? Now, let's say if you are a system which definitely, most definitely needs an RDBMS. Now, what are the scenarios where you would need RDBMS? If you are a system which is very, very transaction specific, right? Like banking systems, financial systems, or there are like scheduling systems which are very, very uh, sensitive to transactions and very, very sensitive to race conditions, where there's a chance where two users can change a single row, and we have to avoid that. In those cases, you would prefer to use an RDBMS system. And what are the cloud service providers which are providing you amazing free RDBMS system? It was Oracle, right? So the next thing is NoSQL databases. So there are a lot of NoSQL databases which are present. Amazon has, like we discussed, DynamoDB. Then Firebase, which is a Google product, has Firestore. And then you have MongoDB, which you have heard of. These are all document type databases. Then let's say if you are building something related to social network, what would you use? You would want to use a graph database, which is Neo4j, and most of the service providers, cloud service providers today have Neo4j as their one of the services which they are providing. Now, let's say you are building something for data analytics or for ML, and you need to store huge amount of data. What would you use? Basically, all these things can store huge amount of data, but for ML systems and analytics and stuff, you need a specialized type of database, which are columnar databases. If you have heard of Cassandra or HBase, these kind of databases, they are columnar databases, and that's what you would use. And lastly, finally, file storage. Uh, one of my favorite file storages are Google Cloud Storage and Amazon S3, which I have used personally, and they are really good. They have very good security if you know how to configure it. Because I mean, I don't know if you have heard, but there have been scenarios where people were able to get data out of others' S3 bucket. This happened with Byju's, and this happened with another company as well, where a lot of their data was leaked from Amazon S3 bucket. They do provide very good security features, but we have to know how should we use them. All right. So now, let's say if you're building a very small application and you're new, it's often very, very easy to have those applications in NoSQL database using a document type database. And I would almost always prefer to use a NoSQL database for such reasons. Another scenario where NoSQL databases are often useful are when you have to read your data very frequently and you need very low latency. So how these NoSQL databases help, or document type databases help you is, sorry for that, really sorry for that. How these NoSQL databases basically help you is that they are denormalized databases. So all their data is at one particular location, and when you're reading that data, all that data comes to you at once. That's not the case. That's often not the case with RDBMS, where you have data in different tables, and you have to join that data and get that data. Uh, you could denormalize your RDBMS tables, but that's not ideal in a lot of scenarios. But in certain scenarios, they are really, really ideal. And I have developed certain applications where we have tried to denormalize data, and I'm a big proponent of having denormalized data in RDBMS, but that might not be ideal for each and every case. All right. So these are the scenarios where you can use RDBMS and NoSQL, and almost all the service providers have these things. I would again, I always prefer to use free services. So if I have to use RDBMS, I have not used RDBMS till now for any of my systems, because I mean I build
I mean, for my personal projects, for in my previous companies like Google, no, Google is my current company. Sorry. So in my previous companies like Oracle and in my current company, Google, we almost always use RDBMS because there is no there's not a single scenario which cannot be handled by RDBMS. If you are doing your data modeling correct, you can do almost everything using an RDBMS. And if I give you an example, people say that RDBMSs do not scale, but a system like Reddit still uses MySQL. And their initial application was built using MySQL. Now they have spread across to a lot of different storage systems. They have Cassandra, they have a lot of other storage systems which they are using for storing their own data. And mind it, all of that again is deployed on cloud. So that's when I would use RDBMS. Now, let us talk about file storages. Now, what would you store in a file storage? Basically, you can store everything in your NoSQL database or your RDBMS as a byte string or as a base 64 string. It could be an image, it could be a video, or it could be a PDF file or anything. But these are not ideal storage systems because the way they are designed and the data structures they use, like most of the RDBMS, one of the famous data structures which RDBMS systems uses is B trees. And even with NoSQL databases, the way they store their data is not very ideal for storing binaries, right? So for those scenarios, what we do is we use a file storage system like Amazon S3 or Google file storage system where we should be storing our data and securing our data. These are nothing but basically solid state drives, SSDs, where which huge SSDs which are shared among different people, different clients, and you can have your own partition, you can have your own buckets of such SSD drives, and you can store your data and retrieve your data from the systems. So always use these file storage systems. Amazon S3, I'm not sure if it's how much it has a free tier with file storage, but Google Cloud Storage also has a free tier. But one of the things it charges for is network egress and ingress. Uh, basically how much data you are ingesting in your cloud storage system and how much data is going out of the cloud storage system. Oops, I think I missed a couple of questions there. I'll take them up right now. So Krishnu says, cluster in Kubernetes not clear. Can you explain it again? All right. So what happens is, let's say when you have uh, tens of thousands of users accessing your application at once, if you have a single server or if you have, let's say, 2 or 3 servers, those servers would not be able to handle your requests because all of this requires a lot of computing power, right? And a lot of RAM would be required for all that requests which are coming. So what you would want to have is you would want to distribute your user requests into multiple servers. Now, let's say you start distributing your request to multiple servers, and now the request now goes to 3 servers. But what happens is when you have 10,000 requests coming. So 10,000 requests doesn't mean you have 10,000 users, but you can have 1,000 users who are interacting with 10 different services, which is uh, increasing your network load to 10,000 requests. Or let's say it can uh, go to 1 million requests as well in very rare cases. In such scenarios, what happens is what happens is you cannot just rely on having 3 or 4 servers, or you cannot keep adding more servers to your system. So what would you do instead? So instead, what you would try to do is you would try to have create clusters of your services. Let's say you have a login service. All right, you keep 3 servers for your login service, which will only handle your login service. Now you have another service, which is, let's say, order service, which will only handle order. Now, let's say you have a third service, which will only handle payments. Now, what happens there is, let's say you have a huge load on payment services, your login service and your order service would not be impacted. What you would do is, what Kubernetes would help you do is Kubernetes will add more servers if it sees that there are a lot of requests coming. Now, when the requests reduce, Kubernetes will itself reduce that load. All right. So that's how you divide your shard or divide or partition are the terms which you usually use, your requests, and you ensure that if there is traffic, huge traffic on a single service, your other services are not impacted by it. I hope that clarifies. What are the benefits of using artificial intelligence? All right, I have a very interesting slide for that, Vibhor, and I'll definitely come to that towards the end of our session, and I hope you will like it. And we have another question, which is by Deepak. Deepak says, will cloud services replace the Microsoft desktop? Uh, I don't know. I understand your question, Deepak, correctly. So Microsoft Desktop is basically, if you mean services like Microsoft Word or stuff like that, then yeah, definitely things are changing because like I'm using slide which is provided by Google, and basically what's happening here is it's a software as a service deployed on cloud, and we are able to use it. And it's really useful because I can use it anywhere and on my device, on my laptop, anywhere. If I would have used uh, if I would have used a PPT, a Microsoft PPT, I wouldn't. If it's on my phone, I would have to spend a lot of effort to send it on my laptop or on a different device, let's say on my friend's device where I have to show it. Right. So I think, yeah, I mean, cloud services are going to change the scenario a lot. And I think now Microsoft also has these services over cloud, but they are not used as often as Google. I mean, I think. Share something about Google Life and how to apply. We'll come to that later. Or you could ping me on LinkedIn and we can discuss it there. Or join the Discord channel, which is there on LinkedIn. We can discuss about it. Sir, would like to know more about your journey from start. All right, we'll discuss about it as well later. But yeah.
Yes, sir. I have to give your insights about your journey from working as a trainee in Simon's Healthcare till working as a software development in Google. So you have to give some insights about your training journey.
All right, I'll I'll talk about it towards the end. I'll have 5 more minutes to my slide. Let's just finish it and then we can discuss about it. All right.
Okay.
Okay. Yeah.
So, as we conclude today's enlightenment webinar on cloud computing and its impact on software development, I would like to extend our heartfelt gratitude to Mr. Costa Sarkar. His deep insight and valuable experience have provided us a comprehensive understanding of the transformative power of computing in our field. Mr. Sarkar expertise and engaging presentation have left us all with a greater appreciation of the technological advancement shaping the future of software development. We are immensely thankful for the time and effort he has dedicated to share his knowledge with us today. A big thanks to you as well as to our wonderful audience. Your participation and enthusiasm are what make these events successful and impactful. We appreciate your
Uh,
attention, your
Wait,
questions.
Dipanshi, I think you missed it. Mr. Kostav has something more to share. He's remaining with 5 more minutes. Okay, then we'll conclude.
Okay, definitely, ma'am. You want to share? I thought sir has said that. I'll
No
just
issues, no
conclude the
issues.
meeting.
No issues, no issues. Actually, yeah.
Yeah,
I mean, I had a few more minutes left, but yeah.
yeah.
All right. Let's move forward. How do you, yeah, we'll talk about AI and machine learning as well. I just want to, before we jump to AI, we have a slide and I'll discuss very in detail what we have with AI. But let me talk about a little bit around uh, what you should use when you are using cloud computing. So should you be working hard or you should be hardly working? All right. So it depends upon at what stage of your system you are, whether you are a mature system or you are a very new system. So let's say if you are a very new company or a person or basically doing your own portfolio project, so whatever. So you should always try to use managed services. Now, what I mean by managed services is that like Amazon provides cloud storage, Google provides cloud. Amazon provides S3, Google provides cloud storage, and then we have managed databases in Amazon like RDS, and in Google like we have Google Cloud SQL. So these are all managed services. What they do is they help you scale up and down your services by themselves. Now, if we can either use that or we can have our own VMs and our own machines where we are deploying our file storage system or where we are deploying our database systems. Now, what happens is it makes a lot of sense for huge companies to have their own systems and their own databases, which they would manage on clouds or on cloud VMs, because it is relatively cheaper. How does it become relatively cheaper? Because their systems are huge and they have very, very talented people who can devise systems and who can devise softwares which can manage all the systems. But for a company which is small or a startup which doesn't have that much human capital, what they would rather do is they would have managed services. They would pay a little more, but what they would do is they would have the benefit of using all the services for free. Like if I give you a small example, so I have worked, I have helped build a very small system called chess neurons for my friend. Now, what we simply did was it was a very simple system where it was hosted on Firebase. The entire front end or UI was hosted on Firebase, and we were directly integrating it with Firestore. All right, and it was a alpha version of that system. Now the system has matured into a much bigger system than what I'm talking about, but it was a very simple system and it was very good for a POC and to check whether users are liking it or not. I didn't have to make all the effort of having my own hosting system or having my own database. I used all the managed services. They scale. So we had about thousands of users in a span of 2 or 3 days, and it handled all that traffic by itself. I didn't have to think about adding more servers or whatever. So it's always better to use managed services which the cloud service providers are providing us. All right. Now let's talk about the next thing. All right, and I think we all have heard this. It's just AI. All right, so yeah, so we have all heard this, and we all know about what's happening with all the AI things which are happening to our system. So let's move forward. Yeah. AI. So I got a few questions around how AI is changing this entire thing, and how AI is going to change the software development and how cloud computing is helping it. Now, AI is something which is very, very expensive, and we can see that from this gentleman in the very middle, Jensen Huang, who is CEO of NVIDIA, and we know how much stock appreciation NVIDIA has gained in past few months or in the past 1 year because of AI, and because of just not AI but also GPUs. GPUs, which sorry, not GPUs, blockchain and cryptocurrency mining. So GPUs are used for cryptocurrency mining and blockchain, and since past 2 to 3 years, their demand has grown a lot, and which has helped NVIDIA to grow a lot, right? So apart from GPUs, what else do we need for training our machine learning models or AI? There is another thing which Google created, is tensor processing units, TPUs, which is basically something which is more specialized towards AI applications and is faster than GPUs. TPUs are usually less energy, as in they are more energy efficient, and they use less energy, and they are basically designed for large scale systems and to be deployed on large scale data centers. And it's very, very specific to AI use cases compared to, in contrast to GPUs, which are uh, more general purpose. Let's say they are used for scientific computing, they're used for gaming, they're used for crypto mining, and definitely they're used for AI. Now, if you talk about all these things, TPUs, you do not get TPUs in the market. You get GPUs, but you do not get TPUs in market. All Where do you get TPUs? You get TPUs only on cloud, and that's Google Cloud. So if you have very, very AI specific use cases, you would go to Google Cloud and you would use TPUs there. Now, when whenever you are using AI, another thing which happens is it's like I said, it's very, very expensive. The reason it's very, very expensive is it requires a lot of infrastructure and a lot of computing power whenever you are training your AI or the data with which you're training your AI. So what are cloud systems providing us for that? There are a lot of things like feature stores, asset registry, like Google has Vertex AI, and Amazon has in Vertex AI. What they do is they use BigQuery and for storing all your data, huge terabytes of data, right? And then you use Amazon SageMaker for again storing terabytes of data for training your machine learning models. Now, once your models are built or fine tuned, you have to deploy your models somewhere so that you can get inferences from that model, right? So these cloud service providers are providing all that infrastructure where you can deploy your models. Now, even before deploying your models, how are you going to train those models, right? So you need those VMs and you need that GPU and you need that TPU power for training your models. Now, once you're training your models, it could happen that you are training and keeping a different types of versions of your models. So where do you keep all those different versions of your models, right? So they're providing you that infrastructure so that you can save all your models. Now, another very important thing which comes with all of these things is you need to know what data did you use to train your model, all right? What kind of transformation that data went through, and what are the kinds of inferences that model is providing. All of that, all of those things have to be connected with each other so that you can debug any issues. You have more information about your model. So all of that lineage is also provided by these cloud providers. So if you do not use cloud, if you are using your own system, it's good till you are using your own system and you are using it for a personal project. But when you are building AI for an entire world or for your customers who are outside the purview of your laptop, you definitely need cloud to reach to your entire population. You cannot do it with your laptop. And cloud providers are providing all that infrastructure, all that expensive infrastructure to you, which is readily available. And definitely, if it's expensive for the cloud providers, it's expensive for you as well. But then there are certain systems like OpenAI, which are providing it to you to a certain extent for free. So we can definitely use that, and they are powered by Microsoft Azure. So Microsoft Azure has this one very interesting thing, which is OpenAI integration. So you could definitely try and use that. And that's it. So let me answer a few questions which we have. So journey of Google, I'll share that. How do we handle data backup and recovery in cloud computing? All right. So it depends upon where your data is. Deepak. So if your data is in RDBMS, is in a database RDBMS, what would you do is you would have replicas of your data. Or what another approach which we take is we take snapshots, we save snapshots of that data inside a file storage. So if you are on an RDBMS or a document database, what would you do is you would have 24-hour snapshot or a weekly snapshot or 3-day snapshot, which you will save at a different storage system, which will be a file storage system. And then you would need to have a system, you need to have a software or a program which can feed that data back into your database. Usually in RDBMS, what another thing we talk about is replication. Basically, your data is replicated across different regions. And so what happens is, let's say if any of your regions, your database, your data is lost for some reason, you have data in another region which you can access your data from. Kashish, you had a question? Kashish, did you have any question? All right, no question. Garima asks, how do you see AI and machine learning evolving within cloud platforms in the next few years? So in the next few years, the way I see it is, I mean, it has already started. And what I would what I would expect from our AI startups and all the people who are trying to learn AI is understand what AI is should be used for. So AI is an extension for human capabilities, and it's not something which is there to replace humans. And I would like to see more applications which are useful for our day-to-day life rather than just wrappers on top of OpenAI. What would you give? What would you give to students just starting their journey in cloud computing software development? What I would really suggest you to do is build a very simple application, like I mentioned about chess neurons, right? It was just a React application hosted on Firebase using Firestore. So start with that very simple application, right? It has no heavy things with servers and all that stuff. Just start with that, and then see how you can add your own server. Probably use a cloud function. All right. Then go to AWS or GCP and use their free credits and try to play around with EC2 servers. See how you can manage permissions to those servers, and start really small. You don't have to learn everything and then try to implement it. You can actually do it for free at a lot of cloud service providers, and they are providing you all that help and support. In fact, GCP, Google, uh, sorry again, GCP, AWS, they would provide you free credits if you tell them that, look, we are students and we want to learn all these things, right? You have to email them and follow up a bit, but they would definitely provide you free credits because they want you to learn these systems. And when you get a job, they want you to evangelize their own system. How does Google Cloud support organizations in terms of stability and handling sudden increase in demand? All right, so uh, I'll tell you a very important case study which I read inside one of the documents in Google. And very briefly, and it's basically public knowledge, so I am able to share it. So what happened was, there is a very famous game, I think Minecraft, which is deployed on GCP, and that game saw a huge traffic peak at one point of time. So there is an entire case study that what happened, and that basically that peak usage in that game caused other services to go down. So Google had an entire case study, and there were very distinguished engineers who worked on this problem, and they found a solution to that problem. And basically what happens is Google has huge resources available with them. So whenever there is an increase in demand, they can just add more servers to your service, and they would not sweat about it. But given that you should have that much amount of demand that the other services are going down, because the scale at which Google usually operates is that if you are not that big enough, right, Google will provide you support in terms of services, but that kind of support you might not get if you are not huge enough. So yeah. But yeah, I'm not, I'm just talking about it from in my personal capacity, and in no way I affiliated with Google. Just just saying, all whatever I'm saying is my personal opinion. Can I learn and choose cloud computing as my career now? I have no prior experience in IT except my BTech degree. I am working as business development manager in an IT firm since last 5 years. So this is more of a career development question, yeah, Nabila. So thing is, you can always learn and move towards cloud computing. You can learn about, so what you can first start with, how you can manage resources, how you can turn up services, turn down services, scale up services, right? And what are the things which are required. Understand why a particular service is required and for a particular use case. All right. So you try to learn about these things first, and then what you can do is you can start with your own company and try to suggest things. But from a career perspective, uh, unless you are very good, or you are ready to start from the very beginning, right, it is going to be a bit difficult, because there are a lot of people who are already very good. So you have to be as good as them. Not that it's not possible, but you have to spend a lot of time there, and you have to spend a lot of effort, and you have to showcase your knowledge. So probably get a certification or something, and then work for some people, uh, do some freelancing gigs, and maybe for free in the beginning, and then start getting paid for them. So you have to prove your metal and then move towards cloud computing. I hope that answers your question. And people who ask me about basically my life in Google, what we basically do in Google. So I'm a senior software engineer there. So a majority of my work there happens around resolving ambiguities. So there are a lot of great minds in Google, and great minds think alike. So I help in resolving ambiguity, ensuring that there is less duplicate work happening, and I help in designing systems which can help our organization to, perform better in certain areas, work better in certain areas. Um, right now, what I'm doing is, in my org, we are trying to develop machine learning capabilities, and I am responsible for, so not me, basically my team is responsible for building the infrastructure for supporting all those ML models which would be used inside our own organization. Uh, Basically, our organization is a vertical inside Google. How to apply at Google? Well, they have a career site, and Google is actually hiring a lot in Hyderabad and Bangalore for a lot of software engineering roles and other roles. So feel free to apply there. Uh, I would like to know more about your journey from starting to reaching Google. Basically, so if I would be very brief about it. I was a BTech in biotech. Uh, I didn't know anything about coding in my college days. So I learned coding when I joined TCS. TCS was, this was great enough to offer me a job, and it was great enough to teach me coding. So that's where my coding journey started. So I joined TCS. I worked on a banking web application. Then I went on to become a data engineer. When I was a data engineer, I read a lot about distributed computing and storage systems. I read a lot about different kinds of systems, and then I thought that currently my abilities are not growing. I'm not learning enough, so I wanted to move out of TCS. So then I moved to Oracle, and there in Oracle I built systems which were responsible for migration of data from on-premise to cloud. At that time, Oracle was moving their systems and all their data. So I built one of those data which moved one of the entities from on-premise to cloud. And then again, I thought that things are slowing down and I need to have some more. I wanted some more challenge. So I again started looking. Honestly, I wasn't expecting it, but somehow I got into Google, and they thought that I would be a good fit for them. So then I joined Google, and I started working for Google, and I have worked on a lot of projects inside Google as well. So refer me in Google. Thank you so much. Sure, sure. Why not? Okay. Can I learn to choose car? Okay. All right, Dipanshi, I'm done now. I'm really sorry for going aboard time. I hope you liked it. And if there are any questions which you have which we are not able, which I was not able to answer, feel free to hit me up on LinkedIn or GitHub or Discord, wherever you.
Definitely.
I'm done. Over to you.
Okay, so a big thanks to you as well and our wonderful audience. Your participation and enthusiasm are what make these events successful and impactful. We appreciate your attention, your questions, your eagerness to learn and engage. Thank you once again, Mr. Sarkar, and thank you to all our attendees. We look forward to see you at our future events. Have a great day, sir.
Thank you. Bye bye.